Hello, everyone. Welcome to this session. First of all, I'd like to say thank you so much for being here today. Thank you for your time. Really appreciate it. My name is Emerson. I'm a senior software engineer at Gilt. So it's on behalf of Gilt's lovely engineering team that I'm here today. And I also have here with me Derek Chiles from the tech leader team from AWS. And today, we're here because we want to talk to you guys a little bit about the path that goes from the monolithic world into the microservice world. Now, just before I begin, can I just ask, just raise your hand, who here is on a monolith today and is looking to go to a microservices or is in the process of doing so? Raise your hands, please. Okay, it's quite a lot of you guys. It's great. So there's going to be quite a lot of takeaway from this session. But for those of you who raise your hand, there's going to be even more. So I really hope you guys enjoy. OK, so let's get started here. So that's what we're going to be talking about today. So why microservices in the first place? We'll go through the migration process and some of the challenges you're going to find in there. We're also going to talk to you about Gilt's journey, right? Some of the challenges we've found when we went through that migration and how we solved them. And also going to talk about some standards and best practices that you can use when you're going through that migration yourself. So let me just start by talking a little bit about Gilt. And as I do so, also try and give you guys a glimpse as to, why does Gilt even need a microservices architecture in the first place, right? So Gilt is a flash sales website. What does that mean? Well, it means that we have those special sales that go live every day at noon on US time. And these sales, they feature different types of products from different designer luxury brands, and they're sold at a pretty good deal. So what happens here under the hood is when these sales, they go live, we get this huge wave of customers that rush to our website in order to get a good deal, right? And, oops, I'm sorry. There. This is what it actually looks like. That's the actual graph of our checkout service over 5 different days. And what you're looking at here is those spikes on user traffic, which happen when we have those sales going live. So this obviously puts quite a bit of stress on our technical infrastructure. And the most important aspect of this is it really hits different parts of our system differently. So some parts are hit way harder than others. So there's a question that a lot of you are probably asking yourselves already out of this. And it's a question that we had in our minds at some point in time, and we were struggling to find an answer. Oh. Sorry. So back to the question. How can we scale things up independently? Right? That's pretty important for us. Around the same time, there's a couple of other questions that we were also thinking about and trying to find an answer. First, how can we arrange teams around business initiatives? And that's pretty important because it essentially means giving those initiatives the dedicated resources to keep pushing them forward. Also, how can you make it easy and fast to push change to production? Again, it's pretty important because this really boils down to having the ability to push features and even bug fixes as well faster to production. So the answer to those questions, for us, it was microservices. So what did we do about that? That's a little bit of our history. So back on the left there, back in 2007, we had our old Ruby on Rails monolith, single data store and all that. So from that, we decided to break that bad boy down into a number of Java services and front-end applications as well. We did realize at some stage, though, that a lot of those Java services, they actually became monolith themselves. So we broke those further down into now real microservices now being written in Scala. We also wrote a ton of new services as well. We broke down our front-end apps into lots of smaller front-end components. And that's pretty much where we are today. We still have a few of those Java services lingering around. And our monolith is still there, but it's really just for the admin part of the site. Gilt.com is actually running on a microservices architecture today. Right, so We used to run all of that in a data center, right? And then we decided, all right, let's go to the cloud. And then we decided to go to AWS. The way we've done this migration was we took all of those services and we've dropped them into what we called a legacy VPC. At the same time, we created a number of other accounts in the AWS, one for each of our departments. And we assigned teams to those accounts. So as those teams were working and writing new services, they would write those services to the account that they were now assigned to. At the same time, these same teams, they were also moving services that they owned from this legacy VPC into the account that they had been assigned to. So the nice thing we get with this is we get this really nice teams structure where we have lots of independence, lots of autonomy, and really most importantly, we get lots of initiatives happening in parallel. Right, so I think I can safely say that Gilt has successfully gone from what was a monolith to a microservices architecture, right? But when you're considering doing that yourself, I think it's important that you look at both architectural styles and then you see what you'd get with each of them, and then be able to fully visualize what the advantage that you're going to get when you go through microservices architecture, right? And I think this is a pretty good representation of this. Because, for example, there are a couple of things which are actually simpler on the monolith world. For example, deployments and intermodule refactoring. There's a flip side of that, though, in which there's actually pretty good opportunities with regards to those two things. For example, in terms of independent deployment pipelines and strong API definitions in the microservice world. And then there are also things where microservices just does give you an advantage. For example, graceful degradation, just being able to much more easily horizontally scale your services as well. And finally, with technology diversity, just having a wider range of technologies that you can choose from, which for me, I think that's pretty awesome. So that was a little bit of Gilt's history, how we went from A to B. But how do you guys actually do that now? Let's start talking about that. And I'm going to begin this discussion by talking about the organizational changes that you should see as you move into microservices land. Right. OK. So that's how things are organized when you're on the monolithic. And probably a lot of you are familiar with this, right? Essentially, your organizational structure is mirroring your application architecture or vice versa. Then on microservice world, things are quite different now, because instead, you now have to start thinking about organizing your teams around business initiatives, right? For example, accounts, an accounts team, a personalization team, mobile team. At Gilt, we have things like a checkout team, an email and push notifications team as well. So once you organize your teams that way, eventually you'll get to a point where you have to start thinking about how do I compose my teams? And when you get to that, you have to start thinking about ingredients. What are those ingredients? Front-enders, your back-enders, data scientists, etc. And keep in mind that each team will have different needs. So don't try to come up with a fixed composition for your teams, right? Instead, just focus on putting ingredients together in a way that makes sense for each team, so that each team will have what it needs in order to operate independently. So when you put those ingredients together in terms of size, you're really looking at small teams, right? Probably between 3 to 5 people. And generally speaking, that's true at Gilt. But it's not really something that we have set on stone. For example, that's my team. That's us trying to look normal in a picture, trying really hard. So it's the 7 of us here, right, which is considered slightly large for Gilt standards. But we have all the ingredients we need. We have data scientists and back-enders. We're still small enough as well. And we're part of the same initiative. So it makes complete sense for us to be together as a team. Right, so once then you organize your teams like that, you give them the ingredients that they need, really you end up with a number of independent teams who will have full ownership on the service that you're going to be having in production. And when I say ownership, I actually mean a list of things. For example, requirements. Those teams will be responsible for defining their own roadmap. Quality, the teams will also be responsible for testing those services, making sure that they're stable in production. Deployment, the team is also responsible for releasing new versions of the service that they own. Source code, the team owns a source code for each of the services that they own, so changes to that source code have to be reviewed by a member of the team. And finally, with technology selection, the teams also have some freedom to choose the best set of technologies that they're going to be using for the service that they own. Okay. I'm sorry again, this just keeps on jumping. Okay, so let's talk a little bit about the architecture changes that you should see in the microservice world now. So that's how things are on the monolith. Again, a lot of you are probably familiar with this. There's not a lot there. Your single deployable, a number of modules, and then your single centralized database. On microservices now, things start to change. So now you have a much more broken down architecture, right? You have all these specific services for specific functionalities. So for example, an account service, a cart service. At Gilt, we have things like a waitlist service, a checkout service, and a few hundred others as well. There's a few things to pay attention to here. First, each service has its own private data store. Also, each service will have its own binary, so it can be deployed independently. Finally, each service also has its own load balancer, so it's much more easier. It's easier to scale up or down those services. If you're on AWS, you might also consider API Gateway as a facade for your services. And with that, you get out-of-the-box things like rate control, authentication, and a few other things. Now, let's just quickly pop the hood here and look at what a service actually looks like. So this is the typical stack for a service at Gilt. And what we have here is we have DNS, that's the entry point for the service. That's how you talk to that service. In a load balancer as well. Then an auto-scaling group, so we get at least some guarantees with regards to the minimum number of instances that we want that service to be running on. As a number of EC2 instances, obviously, a private data store, Docker registry, and a lot of our teams are using actually ECR for that. A CloudWatch log group as well, so we can push log messages for that service. A number of metrics as well, and then on top of those, a number of alarms. Those alarms are hooked up to an SNS topic, and that's per service. That SNS topic is then hooked up to our paging system. So when any of those alarms trigger, whoever is on call on the team is going to get paged, and we'll know production is probably on fire. If you're wondering about the size of those services, this is the distribution of the instance types for each of our services. And as you can see there, the vast majority of our services are actually running on a T2 instance, which are the smallest and cheapest instance you'll have in AWS today. Okay, so there was architecture of microservices in a nutshell. But how do you actually go from the monolith to that nice architecture? How do you get there? Let's talk about that now. And I'm going to illustrate this process using a pattern called the Strangler pattern. It's a pattern that Martin Fowler has actually written about before on his website. So if any of you are looking for more information about that, there's actually a good bit of information on his website about this pattern. The basic idea about the Strangler pattern is that you're going to be building your new system around the edges of your current system. So they will coexist for some time. So that's our monolith here, right? Three modules. The first thing I was going to say is, once you're committed to breaking down your monolith, there you go. Once you're committed to your monolith, if you have a new feature, don't stick it in the monolith, right? Instead, just identify what is the business domain of that feature, and then just write a new microservice for it outside of your monolith. You may find that you may need that microservice to talk back to the monolith, and you can achieve that with what's called an anti-corruption layer, or ACL. And the ACL here really it's a translation layer. So it's translating types from the microservice to the monolith and vice versa. And the key idea here is just to keep your microservices clean and not polluted with types from the monolith, with the API of the monolith. So with that, eventually, you'll have to start moving to actually extract things out of the monolith. And the key principle here really is just really start simple, right? In this case here, I've started with the user service because it's got no dependencies back on the monolith. That means I don't have to integrate it back with that monolith. The monolith does need to talk to that service, obviously, but you can easily achieve that by just redirecting the requests that were going through your old user module component or whatever in your monolith. Just redirect the requests to now go to your brand new user microservice. Once you're past that, then if it works, no, please.
Here.
Sorry, I always forget, I have to point there. Right, once you're past that, then you can start taking more complicated services, right? So services where you will have to talk back to the monolith. And again, you can make use of the AntiCorruption layer for this. Keep your microservices clean and tidy. Once you're at that stage, really, it's just a matter of perseverance. Just keep pushing. Don't give up. Just keep moving until you have moved either everything that you wanted to extract out of the monolith, or you literally strangled the entire monolith yourself. And at that stage, really, all that's left, you just get your services to start pointing and talking directly to each other. And with that, I'd like to hand it over to Derek.
All right. Thanks, Emerson. So next, we'd like to talk a little bit about data management. So we've covered sort of the architectural and sort of the culture and team organization aspects here. And as soon as you start to think about splitting off a microservice and creating an independent entity, one of the first things that you're going to need to think about is how you're going to store the data. And looking backwards for the past few decades at least, by far the standard here for the monolithic architecture has been a big monolithic database that sits alongside that big monolithic application. So you have lots of people using the same database. You have a big complicated schema. You have a lot of people that are sharing that resource. And one of the great things about moving to a microservices architecture that you want to embrace is this concept of decentralized data stores. So one of the fundamental things here is every microservice has its own private data store. There's no sharing across services. And you're able to realize some great benefits by sort of agreeing to this. And the first one, and maybe the most important, is freedom of choice. Developers love to be able to pick the tools that they want, right? And so if you're starting with a blank slate, as a developer or as a service team, it's really up to you to pick the right technology for the job. And of course, there's a lot of options on AWS. So that's great. Another key point here is you have low-impact schema changes. So with a big monolithic relational database, often it can take a long time to get everybody to agree on a schema change, agree on a date, and everyone's got to move forward at the same time, right? If there's a problem, you're going to have to roll it back. And that's just going to kill your velocity, right? So as you move forward into microservices, you're able to change the schema at will, right? The service team owns the schema. Nobody else knows about it. You could be changing it multiple times a day, right? So you're able to move much faster. And finally, you're able to scale independently. You may have some of these services that are very small. They're just taking a few requests. You can save money by having a very small data store on the back end. And next, it's interesting to take a look at the different options that are available in AWS for storage. Again, I think many of us are tempted when we're used to a monolithic model to look at everything in terms of a relational database, right? That's been the sort of king for the last 30+ years, and it works very well for problems and questions that are well suited to relational queries, to SQL queries. But since we have lots of options available to us in AWS, what we want to do when we're building a new microservice is think about the data access patterns first, right? How are we going to be writing the data, and most importantly, what are the patterns for reading the data out? And then we want to work backwards from that data access and then pick the right technology for the job. And in some cases, that may be multiple data storage technologies inside the same service. So for example, you might be building a shopping cart service that could lend very well to DynamoDB and a key value access pattern. So rather than shoehorning that into MySQL, use DynamoDB, right? Use the right tool for the job. You may want full text search. That's something that could be accomplished probably better with Elasticsearch than trying to put that into a relational database. Or you could have object storage, for example. So let the service team pick what works well for them. Could be a single database. Could be a relatively sophisticated backend with lots and lots of different data technologies. They're all talking to each other. I guess most services are unlikely to have this much complexity behind them. This may be an indication it's time to split that service up. But certainly, if you have some heavy lifting to do in the background, you could design an arbitrarily sophisticated backend for your data storage based on what you're looking to do. So another question that comes up from customers as they're going down this path towards microservices is, OK, so I've broken up my big monolithic database into lots and lots of little pieces, dozens or hundreds of pieces. Now I don't want to put it back together again, right? So how do I do that? In the old model, it was easy, right? I had a big database. I could dump it to a data warehouse, or I could just run some queries against it and do my business intelligence roll-up, for example, or my analytics. So let's talk through a few ways that you can think about doing data aggregation in this sort of new microservices world. The first way is probably the most simple. It's the pull model. And essentially, you write your application that needs to do this aggregation work. And you just have it go through the front door, go through the APIs, pull the data in that it needs, and do the aggregation. I suppose that's the most sort of pure from an architectural standpoint. And it's fine for small amounts of data. But if you're going to be pulling a lot of data or all of the data, that's probably going to put a lot of pressure on your APIs, right? So probably not the most efficient thing to do. So what we see a lot of, I would say this is the most common thing that we see, is a push model. So this requires some collaboration between these different microservice teams. And they're all going to agree to dump this data to the same place. Very commonly, that's S3. S3, super durable, very inexpensive. And once data sits in S3, you can do all sorts of analytics on it. You can put it in Redshift. You can do EMR queries, for example. So you can just have all these services agree, dump that data to S3. You could also think about using Amazon Kinesis and just all push to the same stream. If it's log data, you could think about pushing all that log data to CloudWatch Logs. So pick the technology that works, have everybody dump it there, and then aggregation becomes very easy. If you outgrow that model and you need to get a little bit more sophisticated, then you can think about a publish-subscribe model. So in this model, again, these different services are going to agree where they want to push the data. But they're going to push to different swim lanes or different topics. So you could use SNS for this. You could use Amazon Kinesis, for example. Publish that data to the right topic or to the right Amazon Kinesis stream, and then the folks that need to consume that data can grab it. You might be tempted to do this last pattern and make a composite service. And if all else fails, you certainly could think about doing this. We would advise you to think very carefully before building one of these composite services. What you're saying here is, I understand the rules, which are very tight service boundaries, no sharing the data stores, and we're going to break the rules because it makes sense. And so think very carefully about that. As soon as you start down this path, it may be efficient, but now you have tight coupling again. And if the owner of the user service wants to change their schema, they're going to have a velocity hit. They're going to need to go off to this other service and ask them to accept a change. So far and away, I would say the push model is what we see the most of. And we would suggest that you start there. So next, let's talk a little bit about API discovery and API management in a microservices model. We'll start with API discovery. And what we mean by that is simply when your service comes online, your application logic comes online, it knows which services it needs to call out to. It's got to find them. How is it going to do that based on the environment that it finds itself in? And the advice here is keep it simple if you can. For example, this is the model that Gilt uses. It works very well for them. And it's simply to use DNS. When your service comes online, it knows the name of the service that it needs to talk to. It knows that the company name is example.com. And so the only thing it needs to figure out is what environment it's running in. And it can construct the DNS name of the service. That's typically going to be a CNAME, right, an alias that's going to point at an Elastic Load Balancer endpoint or an API gateway endpoint. It's a very simple solution, very flexible. As far as how to find what environment you're running in, you can do things like if you're running on EC2, just push that environment name down into the EC2 instance metadata at instance launch time using the user data. And the service can check that, construct that URL, and go find what it needs to find. That may be not sophisticated enough for your use case. You may outgrow that, in which case there are a lot of great options out there, software vendors. So Netflix, for example, has Eureka, there's etcd, there's Console, and of course Apache Zookeeper, sort of venerable solution for this. And these have some other advantages as well. They have some more sophisticated logic for health checking and failover and short-circuiting. So if you want to get more sophisticated, you can do this. Just keep in mind, now somebody's got to manage this new service. They've got to fix it if it breaks. They've got to make sure that it's performant and that it's scaling well. So you're definitely taking on some complexity and some administrative overhead if you go down this route. And this is a pretty straightforward approach if you go with it. Essentially, the service registry is going to be the location, the repository of knowledge for the location of all the services. They know to register when they come online, and when a client comes online, it just queries the service registry, and there can be some logic in that service registry to do things like failover if needed. So let's talk about API management for a minute. This is sort of a grab bag topic of different things that you sort of ideally have inside each of your service APIs. And again, as you move into a community of dozens or hundreds of microservices, it becomes important to standardize on some of these things. If everybody's picking their own technologies, things could get complicated very quickly. And so these are things to think about in terms of API management. One of them is enforcing API consistency and making sure that everybody's speaking the same sort of patterns for their REST endpoints. Another one is to monitor key metrics. So there's 3 metrics that you want to make sure at a minimum all of your services have. And that's the request rate, the request per second, the error rate, and the service latency for each of the method calls. Super important that everybody is able to collect those and publish them somewhere. Ideally, you're going to have the ability to do read-through caching. We'll talk a little bit more about that later, but that's a very helpful thing to be able to do to take some pressure off of the other services. Authentication and authorization, commonly needed, especially if you're operating in a regulated environment, for example, or if you're looking to bill for the services that are being called. And finally, the ability to throttle. So that's a defensive mechanism. If you have a misconfigured client that's hitting your service really hard, or if you're just overwhelmed with performance and you need to take some pressure off so that you can figure out what's going on, throttling is a great ability. So there are a few ways to go about this. You could certainly roll your own versions of each of these using software off the shelf or build it yourself. There are also some great software packages out there like Apogee, WSO2. We have customers that are running those as well. But we'd be remiss if we didn't mention that Amazon API Gateway is a purpose-built service that offers all of this stuff. So if you're at the beginning of this journey and you're thinking about how am I going to handle the API management, we definitely recommend that you take a look at API Gateway and see if it can suit your needs. It enforces API consistency with Swagger. It automatically publishes those key metrics that I mentioned and some other ones to CloudWatch, so you've got that covered. You can click a button and have read-through caching. And you can do OAuth 2 and IAM for authentication authorization and throttle and meter on a per method basis or on a per API basis. One other benefit with an API gateway pattern that you can take advantage of if you start off by using an API gateway is Emerson mentioned the strangler pattern. And so you can see here that the clients going forward are all talking to the API gateway, right? That's the first change that you make. And then behind the API gateway, you have your monolith, and you're just routing all the traffic to that monolith. And by doing this, you can start to pick off these microservices, move them off to be implemented by Lambda functions or be implemented by Elastic Load Balancer in EC2 or Elastic Beanstalk. And you can take your time and spit these off in the back end, and the client never knows that anything's changing. So a very powerful method there. And finally, on APIs, just a list here of some kind of do's and don'ts when it comes to versioning. This is a question we get a lot, right? You're doing lots and lots of deployments, which Emerson's going to talk about in a minute here. You're moving super fast. I want to change my API, but I don't want to break the other folks. And so you want to embrace the ability to have lots of velocity here. And that means not having major version changes unless you have to. Right? So it's OK to add new methods, new services, new parameters, new types. Right? That's not going to break anything. It's OK to mark things as deprecated and politely ask your neighbors to stop using them. What you don't want to do is have a disruptive change without some negotiation at first. And keep in mind that every disruptive change, every major API version change, is going to you're going to take a velocity hit. Right? Everyone's going to have to stop what they're doing and upgrade. So think really carefully about those and try to minimize them. And on the other side here, what you don't want to do is delete methods, delete required parameters, or add them, rename things. That's going to break folks. And it's certainly not a nice thing to do to your neighbors. So negotiate changes when you need to, release a new major version of your API, try to keep it to a minimum. So speaking of deployment, I'll hand it back to Emerson.
Thanks, Derek. Sorry. All right, so let's talk about deployments for a bit. Pushing things to production, hopefully without breaking it. So that's how things are on the monolith when it comes to deployments. So really quick here, one deployment pipeline. You can have different stages as part of that pipeline, and your releases with changes across different modules. So a lot of you are probably familiar with this. Now, in microservice world, instead, now you have to start thinking about having separate deployment pipelines for each of your services. Those pipelines, they can be different. So one service can have stages that on its pipeline that another service doesn't have. And that's fine. The key idea is still have independent pipelines for your services. If you're on AWS, you have quite a lot of options for that. You can go with code deploy, beanstalk, which we have used at Gilt in the past, or code pipeline, and you can mix it up with a number of other technologies as well. The nice and important thing about doing these independent pipelines is that you can now then just pace your deployment independently for each of your services, right? You can go as fast as you want or you have to, or as slow as you want or have to. But not only that, you can also now deal with a failing service independently. For example, you can push a fix to a failing service, or you can just roll back that service to a previous stable version independently of any other service. So this gives quite a lot of flexibility, freedom. You can move really, really fast when you have this sort of setup, right? But as good engineers that we are, at the end of the day, it's still our job to make sure that things are stable in production. So it's important to think about independent pipelines, but it's also important to think about phase rollout, right? How can I give my new releases enough traffic that will allow me to evaluate the health of those releases? One way we used to do that at Gilt was with the idea of Bluegreen Deployments on top of Elastic Beanstalk. So we had our own tooling for this, actually. And the way it worked was, let's say I have a current version running in production, say 0.0.1. If I wanted to release a new version, this tool would go ahead and create a new Beanstalk environment for that release. And then it would slowly migrate traffic from instances of the old environment into instances of the new environment. And then would keep on doing that until all traffic had been migrated. The old environment would stay there for a while, for about an hour, just in case you needed to do a rollback, but eventually it would be killed. Today, we are doing this phase rollout. We're relying mostly on code deploy for that. Our code deploy setup is we have one code deploy application for each of our services. And that code deploy application is broken down into 3 deployment groups. We have a development, a canary, and a production deployment group. Pay attention here that the canary and the production deployment groups are under the same ELB, but our development instance is not. So it's got its own load balancer. Also, our development instance is pretty much like a production instance. So it's talking directly to production services. That, and the fact that it's got its own load balancer, actually allows us to do some pretty interesting things with regards to not only phase rollouts, but also testing things directly in production. For example, let's say you're an engineer, you're working on a back-end service, right? What you can do is you can push your changes directly to the development instance of that service, manually test your changes directly against production, and once you're happy with that, you can promote that deploy to a canary deploy. You're then going to have some traffic, some production traffic received on your deploy, and then once you're happy enough, you can promote that to a canary deploy. Again, you can do all of that by deploying to the development instance without affecting production traffic. We can do something similar with our front-end apps as well. We have mechanisms where we can say, listen, I want this request to be served by the development instance of this front-end app. And with something like this, we can test entire features from the front end all the way to all the back-end services involved directly in production without affecting production traffic and without exposing those features to our users. So let's switch gears here a little bit. Let's talk about looking after your services in production. Let's start with monitoring. So monitoring, obviously, really important in microservices. It's what will allow you to judge whether your services are healthy or not in production. When you have hundreds or even thousands of services running in production, this is crucial. You just can't live without it. And monitoring really is about pushing relevant metrics and making those metrics available for people to look at and see whether your service is doing well or not. When it comes to metrics, you can think of metrics, for example, at the instance level. So the memory usage on your instances, the garbage collection cycles, thread count, CPU usage, and etc. You can also think about service level metrics. So the throughput on your service, the latency, your 95th, 99th percentile as well, the error rate. Also related to that, think about the response times for each of your endpoints. Also establish reasonable response times for those endpoints as well. And make sure you alert when those response times are not being met. So this is an example of some of the monitoring we have at Gilt. And I'm just going to go really quickly through this. At the top, this is with Whitney Relic, by the way. We use Whitney Relic a lot for this. At the top, we have the dashboard for one of our services. And what you're seeing in there is we're getting response time for that service, response time for each transaction, error rate, throughput. But the nice thing about this is we can get that not just for the service as a whole, but we can get that per instance as well. So we can evaluate, for example, whether a canary release is doing well or not with something like this. We also use CloudWatch for some of our metrics and monitoring as well. And the first graph here, what I have is this is the remote calls that one of our mobile endpoints is doing. And it's keeping track of the time that it takes for each of those remote calls. With something like this, you can actually go back at this graph and see if there's any of those remote calls could be potentially slowing down your service, your endpoint, which is pretty important when you're doing a lot of remote calls. At the bottom there, what I have is you can think about business-related metrics as well. So it's not just technical metrics. At the bottom graph we keep track of the number of submitted orders for a given time window. And we can actually alert at Gilt when that number is below a reasonable value. So let's talk about logging now. Logging, along with your metrics and monitoring, it's what will allow you to go back to production issues and hopefully debug and find the root cause for those. The first thing I would say when it comes to logging is just push your logs outside of your instances, right? This means that it's easier for everyone to just look at those logs if they have to. It also means that if there's any chance that you're going to lose your logs by your instances going down, you eliminate that possibility. So you eliminate the possibility of losing crucial information for debugging production issues. And in AWS, you have a few options for this. You can go with S3, Elasticsearch, CloudWatch as well. Also have visibility on the whole life cycle. For example, from deployment all the way through your instance startup. Make sure you know what software is being installed in there, your service logs as well, and maybe even reasons why your instances are being terminated. When things fail in production, and they can fail at any of those stages, it's really important for you to know exactly at which step at any of those stages things are failing, so you can bring things back, to life again quickly. Also, separate your logs by service and by instance, and it's probably better if I illustrate this on my next slide. So that's the setup we have at Gilt, the basic setup we have at Gilt for pushing logs in AWS. So we keep one CloudWatch log group for each of our services, and then we have one log stream for each of our instances. What this means is a lot of times you know which instance is erroring out, right? So you can just go to the specific log stream of that specific instance and search through those logs without having to search through a lot of logs that you really don't have to. This setup may not be enough a lot of the time, right? You may find yourself having the need to gather information, not just from different instances from the same service, but also different instances from different services. So when you have that need, you're going to have some sort of aggregation layer, a place where all of that logging information is just centralized and available to be searched. One way we do that at Gilt is we rely on that previous setup I've just talked about. And what we can say is, I want to aggregate the logs for all of those services. So we set up CloudWatch events for each log stream of each CloudWatch log group of each service that we want to aggregate the logs. And whenever we push a log message to any of those streams, the CloudWatch event will kick off a Lambda. The Lambda will have the log message, and then we'll index that log message on a AWS-hosted Elasticsearch cluster. Once that information is in there, it's very straightforward. With Kibana, we can easily search through all of those aggregated logs. I do have to say, though, that information in there will pile up quite quickly. In fact, it does pile up quite quickly. So we have a separate Lambda on a schedule, which runs on a daily basis. And the job of that Lambda is to essentially clean up all data. And I believe we keep 3 to 4 days worth of logs. With that, I'd like to hand it over again to Derek.
All right. Thank you. So for this last section here, we wanted to talk about what we're going to call good citizenship. And we think this is a very important concept in a microservices world. In a monolithic application, you have one big piece of machinery. Everyone has to move in lockstep, right? The deployment either goes out or it doesn't. And so you can have more of a top-down approach about some decisions. But as soon as you start moving into a place where you have dozens or hundreds or maybe even 1,000 microservices, all of a sudden you have a community of service owners and service teams all doing different stuff, deploying into production. And that means that once you're in a community like that, it's important to be a good citizen. And so we're going to talk about some things that make good citizenship. And if you're a service team, if you're a service owner, you're going to be wearing 2 hats pretty much all the time. Right? You're going to be wearing the service consumer hat. Right? You're calling into my service. And you're also going to be a service provider. And so when you put on these different hats, we think it's important to have tenets or sort of key principles that everybody agrees on. And these are things that the service teams can get together, they can agree to, you can write them down, you can put them up on a wall. But when somebody builds a new service, you can point to that and say, it's important that you think about these things. These are sort of the rules of the house. So if you're thinking about being a consumer of a service, one principle, this is Werner Vogel's famous saying, everything fails all the time. That's absolutely the mindset that you want to have when you're a service consumer. If you're planning to call my service, you should assume that it may become unavailable for some number of minutes. It may start to operate slowly. There may be a spike in the error rate. And as you're making that service call, you should be thinking about what you're going to do in the event of any of those things happening. Another thing that may happen is you may be throttled. Again, if my service is having performance issues, I may choose to apply a throttle so I can take some pressure off of it, figure out what's wrong, fix the performance issue, and then lift that throttle again. And typically to a caller, that means you're getting these HTTP 429s back, right? Slow down, back off. So when you get those messages, if you have a retriable failure message coming back, you want to always make sure that you're using exponential backoff. And that simply means every time you have a failure, you have some retry period, you double it every time that you retry. This is super important because the moment that you're having a lot of failures with a service, you don't want to be hammering that service as fast as you can with error messages. That's not going to be helping the situation. Graceful degradation, of course, really important. We'll talk a little more about that. But think about how you can operate in a degraded mode if one of your services that you depend on is having trouble. And finally, caching. And we'll talk a little more about caching here in a second. But caching is a great way that you can take pressure off of the other services that you're depending on. So for example, if you're looking up the first name and last name for an account, that's probably something that's not going to change very often. That may be something you're willing to cache and say, we'll have a time to live of 5 or 10 minutes. So if you put on your service provider hat, there's some other tenets that we think you should think about agreeing to. We think this is a good starting point, and you could talk to the other teams about this. One of them is everybody should agree on what are the standard metrics that we all publish to each other. If I'm having a production issue, I'd like to be able to go to a common place and see everybody's service status in one place. It could be CloudWatch, it could be New Relic. We should pick one, and everybody should agree to that. Again, publishing logs for aggregation should be an expectation. Everybody should be doing that using a common service. Everyone should be prepared to throttle. So do yourself a favor. Start off as you're building out the skeleton and the frameworks for your microservices. Have the ability to do throttling built in. You get that for free with API Gateway. You could build it in yourself. Make sure that you can do that so you can be defensive in case you have a misconfigured client that's hammering your service, for example. Another tenet for a service provider is my service implementation details belong to me. As soon as you start sharing details about how you've implemented your service, people are going to start depending on those, and now you're tightly coupled again, and you're going to break people when you make changes. So if folks are starting to say they want to depend on your implementation details, don't let that happen. Finally, as we talked about, maintain backwards compatibility with your APIs. Be nice to people. Don't force them to accept those changes. So another key aspect of being a good citizen in this community is to standardize on logging. This may sound simple, but again, once you have 20, 50, 100, 500 services, you're going to want to have your logging in order up front. And so do things like standardize on the time format. ISO 8601 is your friend. Standardize on UTC 0 or Zulu time. Again, you don't want to have to go and ask 50 service teams to change this once you've gone down the path. And you may be deploying only in one region today, but AWS has a lot of regions around the world. Tomorrow you might be in 3 different places. So standardizing on time zones is important. And finally, you'll see in orange here, we have these UUIDs. And so those are correlation IDs. And in this big distributed system of microservices, correlation IDs are super helpful. And that simply means that when a request first comes into the system, into the first service, that you pick a correlation ID. It could be an order number. It could be a unique ID that you generate. But pick one, write it into the log file, and then pass that correlation ID down the chain to all of the other services that you call. Everybody agrees that they're going to do the same, and they're going to log that correlation ID. That makes things super easy when you have some kind of trouble that a problem you're trying to troubleshoot in production. You can just plug that correlation ID into your log aggregation service of choice. You'll be able to see all of the log entries that relate to that. Another key thing to do is to paralyze anywhere you can. We talked to Gilt, for example, in their shopping carts or in their checkout service. They realize that they're making between 15 and 20 service calls in order to check somebody out. And they realize that 30% of those service calls could be done in parallel. And so if you think about that a little bit up front, you can actually squeeze a lot of latency out of the overall system. So think about how you can parallelize your requests, and you'll be doing your caller a favor. A lot of languages make this really easy. This is Scala, for example. And so you can think about using models that are built in. When you're making parallel calls, you're at the mercy of the slowest response. Right? So if you've got 10 responses you're waiting on, it's that slowest last one that's gating you on returning to your caller. And so again, something we've talked to Gilt about is if you have a slow responder, you should think about, does it make sense to keep waiting for that slow responder, or does it make sense to return a partial result? And so you can categorize these service calls into service calls that you must have in order to complete the request, or service calls that you can actually get by without. And if you do that exercise, if you have a slow responder, you can actually decide that you're going to return a partial result back to the caller rather than just giving them a hard error message. So this is something to think about in every service, is how you can deal with that slow response. And then a little bit more about caching. So there are a few patterns that you can do here. Again, caching, very helpful in order to take pressure off of other services, not make them scale as much so you can save some money. So you should cache where you can. It may be tempting to do local caching. It's certainly the easiest option. You can have a local cache in the local memory inside your VM or inside your process. There are a few challenges with doing that, though. The first is if you're running in a VM or JVM, you're going to be causing more pressure on the garbage collector, and that can cause some performance issues. It also means that you may need to scale your instance. As your cache grows, you might say, oh, it's time to change instance sizes. Now you're spending more money. So you may be going down that path. And finally, it may be a slower startup time if you now have to do cache warming. So a much better approach is to do a look-aside cache, stand up an external cache. So Elasticache makes this very simple. You can have memcached or you can have Redis sitting to the side of your service, and all of the instances can just go there. They're aware of that cache location. They can look for a cache data. They can expire it out, for example. So that's a good model. We like that. But probably the best, again, is to use a read-through cache if you can. The nice thing about this is, compared to a look-aside, the caller doesn't need to know about it. All they've got to do is make their service call. And then it's just a configuration option inside your API gateway to be able to say, this method is cacheable for this amount of time, and it takes care of the rest. So just to summarize here, we've talked about sort of the organization and ownership. Microservices is every bit about as much about culture change and organization change as it is about technology. So again, we recommend that you get started by thinking about how you're going to orient your teams around business processes, how you're going to populate those teams. Then you can think about how you're going to make this architectural change. You can make your technical decisions. And then finally, we talked about good citizenship. And we really do think that's important. So really think about having this conversation between the service teams, agreeing on what it means to be a good citizen, and write those tenets down somewhere. So with that, I'd like to say thank you for attending. I hope this was helpful, and we hope you enjoy the rest of the conference. Thank you.